Basics of personal computers. So, what do you guys think makes a computer a computer? Used to be pretty easy to figure out, right? You look at something like that old Apple IIe, and you go, that looks like a computer, right? You're looking at beautiful iMac, and you're like, that looks like a computer. Cell phones, they kind of became computers now too, right? You look at your iPhone or your Android. You guys see a theme? I kind of like Macintosh stuff. You got an Android tablet here, right? That's a computer too. What about, you guys remember in the old days, like when I was in elementary school, we had those Casio calculator watches. If you're a real nerd and you had one of those, you thought you were cool, right? I know I did, right? Those are computers too, right? So really, what do you think makes a computer a computer? It's got 4 basic functions, right? Takes an input, does some processing, does some storage, and it gives you an output, right? All those things do that. I have a fitness tracker on my wrist, right? It counts my number of steps I take per day. That's the input. It stores that information. It syncs it to my cell phone later. That's the output. So it does all those things, even though all it is a watch and a timekeeper, right? It counts my steps. So again, our basic steps, we have input. We do some processing, those to and from storage, whether that's in memory or up to a hard drive, and then outputs to a screen, to a printer. In the old days, we had these big rooms or filled with computers. They didn't have screens. They came out as printed output, right? And the input was actually punch cards. So an example of that would be this big old monstrosity. You could see here, right? The input, the keyboard. Output was this printer. They actually didn't even have a monitor to look at the stuff. This is an example of just what computers came from, right? And now we have these things in our pockets that are more powerful than the things that sent people to the moon, right? You look at your iPhone or your Android phone, those things are incredibly powerful. Hardware. So we're going to talk a lot about hardware in this course. We're going to go through lots of lectures about all the different pieces of hardware through your computer. Hardware is the stuff that you can touch, right? You pick up that case, you're like, this is hardware, right? Pick up a piece of memory, you know that's a piece of hardware, right? Hardware failures can occur for different reasons. You can have loose connections. These are all cabled together. They're all based on electrical connections. If you have a circuit board that's plugged into another circuit board through an expansion slot, like those gold contacts you see there, if they don't make a good, clean connection, you can have problems there. You can have electrical issues. Not enough power, too much power, that causes issues. You get physical damage. If I have a broken card, it's not going to function properly. That makes sense. Or even incompatible devices. Hardware can be expensive to repair and replace. For instance, if you fry somebody's video card, it can cost you $200 or $300 to get a new one. If you break their processor, that can cost you a lot of money as well. So you want to be careful with this type of stuff, right? We have input and output hardware as well. Input things are things like mice and keyboards. Nowadays, it's even your monitor with the touch screens, right? Output can be things like monitors or speakers or printers. Monitors to see it, printers to have a physical output. Even 3D printers. Now you can print out little 3D objects, right? Like game pieces. And speakers to give you that audible output as well. So hardware, we do processing as well, and we need to have a central processing unit to do that. Our processing occurs within these CPUs, these microprocessors. It's the act of taking that inputted data that we have and doing something with it to make it usable. For instance, if I take ones and zeros inputted from a CD, it can come out in the speakers as music files. Our CPU is the brains of our computer. All the data it gets in here, it controls everything and it does everything. If your CPU goes bad, the whole computer is going to stop working. Storage. So we said the fourth major function there. We had the input, processing and output. We also had storage. As storage is all the things that we do to keep track of saving this data for future retrieval and use. That can be in our RAM, which is our random access memory, which is short term. The cache, which is actually memory inside our processor. Or even long-term with things like our hard disk, flash drives, USB drives, optical disks like CDs and DVDs. All these type of things are things that we can store things to. Software. So software is going to provide us the instructions that tell the hardware what to do. Without the software, the hardware just sits there. It needs to know what to do. Our operating systems provide us the basic low-level functions for us to be able to do what we need on the computer. So for most of us, that's Windows, right? If you're using a Macintosh like I am, it's OS X, which is Macintosh's operating system. If you have an Android phone, it's actually based on Android or Linux. And this is what's going to control all of your systems on the computer. It's going to allow you to do your saving, retrieving, your changing, your printing, your transmitting inside the computer. You have two types of commands. You have internal commands and external commands. Internal commands are built into the operating system. External commands are things that you load in afterwards. Like, for instance, when I open up a web browser, that's an external command. Or I loaded up PowerPoint, that's an external command. Things like copying and listing directory structures, that's part of the operating system. That is part of those internal commands. We also have application programs, which are a form of external commands, and they're used to create, modify, and store our data. And they are things like Microsoft Office products, PowerPoint and Word and Excel, Adobe Acrobat to read PDF files, Internet Explorer or Firefox or Google Chrome or any of those type of things. They're all application programs. If you like to play video games like World of Warcraft, that's an application file. All of these are software that allow you to do stuff. These awesome things in the top left corner of the slide, those are 3.5-inch floppy disks, right? Really old way they used to load software. I don't think anybody's computer even has those drives anymore. We'll talk about those again when we get to the storage chapter, but just a relic from the past there. And then we have firmware, and firmware is kind of weird, and sometimes students have a hard time grasping this, but it's really a combination of both hardware and software. And one of the things you'll see often is they'll call it software on a chip. And basically what it is it is software, but it's on a physical memory chip component. We have a thing called BIOS, and that is a great example of what firmware is. BIOS is actually basic input output system. We'll have a whole lecture on that one as well. But it is loaded on this chip that's on your motherboard. And so when you turn on the computer, the first thing it does is it goes to that chip and it gets the things of how to take input from a keyboard, how to put output to a screen. All that's controlled by BIOS. This software is on this specialized chip as attached to your motherboard. It's also inside optical drives. So if you have a CD drive or a DVD drive, it's in there. Video cards have their own firmware as well, as do a hard drive, host adapters, network cards, modems, and printers. This software on a chip, it controls the device that the chip is connected to. Most firmware today is actually what we call flashable, meaning that we can upgrade that software on that chip without having to replace the chip. In the old days, if I wanted to upgrade your BIOS, I did pull that chip off the motherboard and put a new chip onto the motherboard. And it required soldering, and it was kind of a real pain in the butt. Nowadays, we can just flash it, as you can see in the lower left corner there, and it'll just update it, and now it's got the newest version. So one of the big things that we've seen in computers in recent years is this idea of componentization and standardization. So when computers first came out, if you went and bought an IBM PC, like all the parts were pretty much IBM stuff, right? If you bought a Mac, it was all Mac stuff. And if you bought a Compaq, it was all Compaq stuff. Nowadays, we can kind of take pieces of each and substitute them around. And the idea is, by doing this componentization, we took this big complex problem like a computer and broke it into subsystems. So we have the memory, we have the processor, we have the motherboard, we have the storage part, which is the hard drives. And we can reuse these and use them in different places. For instance, I have this laptop here. I could easily take out the hard drive from this and put it in Nick's laptop, right? Or put it into Charles's laptop. It'll still work. Standardization, the idea of that is that we have a set of standards that everybody builds to. So in the old days, there was no standards. When you built a computer, you kind of built it however the heck you felt like it. In the early 80s, they all came together and they said, hey, we should probably make this where we're all using the same type of technology. And so a lot of standards started coming out. For instance, they started having this thing called an ISA slot, which was a type of expansion card, so that every motherboard would have this same type of expansion card. You could then swap in and out different cards. Or we're all going to connect hard drives using the same type of cable. That way we all know we're using this IDE cable. And so I can take that hard drive and use it in any computer. It made it cheaper because we could mass produce these hard drives and not have to make a hard drive specific for IBM and a hard drive specific for Compaq and a hard drive specific for HP. It made things a lot easier that way. We use standardization all the time in computers. We have standards for everything. We have standards for our web browsers and how they're going to display things like HTML, or these pictures here are JPEG images. That's a standard. This is the format that we use for imaging. So here is just a front view of a desktop computer. Probably looks pretty similar to the computer you have at home. Maybe not. It's more of a business style machine, but same idea. This is an old gateway computer. You can see we have our CD DVD drive here at the top. Going down to B, we have a memory card reader bay where we can actually put in cards from like our digital cameras. We have our power button at C. Going down to D, we have this headphone jack. The red one right next to it, or pink one, is microphone jack. Next to that, we have these funny shaped D connectors, which are called Firewire ports. We'll talk a lot more about those later. We have USB, which is H, which you guys are probably very familiar with. And this little G, this indicator light, is for the hard drive. Whenever the hard drive is being accessed, you get that blinky red light going on. That's just an example of what a computer looks like. I know you all have seen computers before, right? Yeah, I thought so. Alright. So, every time we finish a lecture, I'll give you a simple question, kind of something that you may have seen on it, that were on previous tests. Just give you an idea of the way they write test questions for this stuff. So here we have a technician's task with upgrading hard drives of a high-end workstation to an SSD, which stands for solid-state drive. We'll cover this later as well. The drive must be configured in a RAID array, but the RAID card does not support an SSD. Which of the following would the technician use to verify in order that the new drop that used to verify and be able to use the new drops? So if we look at this, we have controller firmware, power requirements, file system type, or system BIOS. Now, only two of these things should even sound remotely familiar from what I just spoke about, right? Which ones? A and D, right? You remember the word firmware, you remember the word BIOS, right? And so it's one of those two. And this question we were talking about with firmware, it's software on a chip, and we find it either on the motherboard as part of the BIOS. We find it with optical drives or with hard drive controllers. Here we're talking about hard drive controllers, so the answer should be the controller firmware. It's, let's see, even not even knowing, you can still get down to a 50-50 answer, right? So it helps you out there.